Hello again, Mr. Marno again, Miss Mangiarelli, still on the camera, and I am here in the House of M. So today, or in this video I should say, we are going to collect the data for Lab 2B Newton's second law. And what we're trying to do is look at the difference between balanced forces acting on an object and unbalanced forces on acting on an object. Can I do some background?
Oh, absolutely.
Okay, so as hopefully you learned, when balanced forces act on an object will not accelerate, it will maintain its velocity. So if its velocity was 0, it'll stay at 0. If its velocity was 5 meters per second, it'll stay at 5 meters per second if all the forces acting on it are balanced. If the forces are unbalanced, then that will make an object accelerate, and accelerate proportional to its mass, or F equals ma. So that's what we're looking at right now. So the way we're going to demonstrate this is with the lab setup. You remember the orange car, you remember the stand, you remember the track. Well, here we go. So what we're going to do here is I'm going to let the car go. It's going to go down the track. I am going to record the time it takes to go through gate A, and then I'm going to take the time it takes to go through gate B, and then I'm going to take the time it takes to go from A to B. So these first two are just there, and then from here to there. That's what we're doing. And so we're going to use the timer to do that. There comes the car. So the first one we get is time through gate A is 0.0147 seconds. Now if you think with a stopwatch that you can measure 1/100th of a second, you are sorely mistaken. So that's why we use these photo gates. The second one is 0.0066. And the time through both was 0.3804. That's it. Now I'm going to leave off seconds because I have terrible handwriting. So I'm going to leave those without units, but the units are here. Right? So that's not important here because we already said the units are seconds, even though we have that there. Okay, let's do it again. So we're going to go... And we got 0.0150 on gate A. We have 0.0065.
Do you round it, Mr. Martineau?
On gate... No.
No.
I'm going to
Do
leave
you
all
just take the first two digits?
No, I take all of them.
Oh,
Those are the ones that were reported. So if the machine gave me 4 digits, I'm going to take 4 digits. 3812. Think about what this thing is doing. This can measure to 2/10,000ths of a second, which you can't do. So that's why we use the tech whenever we can. Even though it's not very high tech, it's still tech nonetheless. Third trial, gate A, 0.0149. Gate B, 0.0064. A to B, 0.3823. All right, so there's that deal. Now what we're going to do is we're going to do just... I put that in the wrong spot.
Well, that's okay. Well, that's okay.
Okay. What do we do? What do you want to do? No, I don't want to stop. So...
well, we know that's all right because we're going to give them the data. We're going to type it into the form for them.
Right.
So that's okay.
So currently these are in the wrong spot. So I'm going to make a note here that this is downhill. I'm going to make a note here that this is level. That is my fault entirely. I did not read the sections, and that's my bad.
That's okay.
All right, so here we go. We're going to now move the gates. So they're going to be here.
Yep, down to the black rectangles.
And we're going to go to here. Okay, so now we're just on the level part, and we're going to stop that. Okay, we're good to go there. All right. Yep.
Do you want to make sure the track is level before we collect data? So run the car down the ramp. That's how we check if it's level. We run the car. If the time through A and B are the same, 0064, 0068. So the time through B is a little bit longer. So that means the car was going a little bit slower. So we could do that?
What? I'm not going to do that for 4/10,000ths of a second.
All right, go ahead.
I think that's... We're going to write that down, though.
No, well, good. Run the car.
Okay, we're going to run the car. Here we go. Oh, yeah, we're going to get the data.
Yep.
Here we go. So, we have 0.0069 through gate A, 0.0072 for gate B, and then we're going to have 0.1416 for the time through both. So we're going to do it again. .0067 for gate A. We've got 0.0069 for gate B, and then we're going to have 0.1360 for the time from A to B. And now last trial. And I have 0.00. So it's not broken. We're getting different numbers, but they're not different by a lot, which we expect. 0.0067, time from A to B, 0.1327, done. So that's our data, and that's your data. So now what we're going to do is we're going to clean it up and make sure that it's in the right spots, and we report that again. In the next video, we're going to show you how to calculate the numbers using that ever dastardly tab on the top. So I'll show you about that. So until then, thanks everybody. Mr. Marno here, Ms. Mandarelli on the camera. We'll see you next time. Thanks.